Hey guys, it's Mr. Pendia here, and I'm going to go over some of the problems on pages 19 and 20 in your packet. Right, this is our intro trig practice. This will help you review all the different types of problems that you've seen, and it should get you a good grasp of the test. All right, so let's make sure that we understand how to do this. So the first two questions, I'm going to look at number one. It says determine the measure of these angles in degrees for each rotation. And they've actually given them to us in rotations. So remember, a rotation is like a full circle. All right. So this has gone 3/5 of the way around the circle. All right. Now there's a very important piece of information mentioned here. That is that it is going clockwise. That, remember, means that you are negative. Okay. So this rotation is going clockwise. It's going the same direction as your clock instead of the opposite direction, which would be counterclockwise. And all of our angles that go clockwise are considered negative. So I know my final answer should be negative. So let's actually convert this. We take 3/5, that is rotations, and each rotation is a full circle. So that's 360 degrees for every one rotation. And when I do this, I always like to write my units out. Those are going to cancel each other out, right? When you divide, they cancel. So 3/5 times 360 over 1. And I end up with 216 degrees. Now, we mentioned earlier, really important, this needs to be negative, okay? That answer is negative because it is clockwise. Some people will actually convert the angle first. They'll say, I'm going to make it into a counterclockwise angle. I want to see what the coterminal version is and then do it. But I think it's simpler as long as we just remember, hey, this is negative. Immediately, first thing you saw me write, it's negative. And then I converted into degrees and made sure to mark it as being negative. Okay, guys, so problem 2 will be on the answer key. You'll see that there's a PDF also available to you guys that has some of the other problems solved out for you. So this is a good opportunity. You can see some examples, and then you can practice and you can check your work on there. So let's take a look at problem 4. All right. A compact disc rotates at a speed of 500 RPMs to the nearest hundredth. Through how many radians does it rotate to play a song that lasts 1 minute and 30 seconds? Okay, some key information here. Let's highlight 500 RPMs and 1 minute and 30 seconds. Now, in case you don't know, a CD is how we used to listen to music back in the Stone Age. Okay. Now you guys all have MP3s. But let's figure out what it means by 500 RPMs. So 500 RPMs, that means revolutions per minute. So there are 500 complete circles that this thing completes every minute. So 1 minute gives me 500 revolutions. And I know some of you are having some PTSD flashbacks to physics and chemistry when you start seeing me make these railroad tracks. But it's pretty simple, so don't get too scared. So I know that I want to find how many radians there are, okay? And I start thinking, and I'm like, okay, a revolution is a circle. So each revolution, one revolution, is 2 pi radians. Now notice where I put this, okay? I went ahead and put the revolutions at the bottom to counter the revolutions that were on top. And what that's going to do is those units are actually going to end up canceling out, okay? So I can say, yep, that's going to go away and that's going to go away. Now, the song is 1 minute and 30 seconds. That means this is 1.5 minutes. In case you don't remember, 30 seconds is half a minute. Okay, so where do you think I should put these minutes to cancel out my other minutes? Okay, those are going to end up coming up here, 1.5 minutes, and I'm going to let those cancel out as well. So now I can actually multiply this all together. All right, so all we have to do now is multiply everything together. And we just treat it like it's a big fraction. So everything on top is going to go together. Everything on the bottom will go together. So you should see 500 2 pi 1.5 makes 1500 pi, and that's going to be radians. And on the bottom, I've got just a 1, and there's no units left down there. Everything's canceled out. So finally, my 1500 pi radians is my final answer. And radians is technically not really a unit, but we'll go ahead and write it out just for the sake of it. All right, so on the next section, I'm going to look at 5 and 7, the problems that are highlighted here. And it says, name the quadrant or axis where the terminal side of each angle lies. So overall, this isn't going to be too complicated. We just need to figure out what the angle looks like and where it kind of ends up. So I'll start with number 5. So 110 degrees, so I can say this is 0, this is 90 degrees, 180, 270, and of course 360 degrees. And so if we were going around this, remember, normal angles go counterclockwise. So I would kind of say, okay, 0 to 90 to a little over 90, not quite at 180. So it's got to be somewhere over here. And it goes this way, okay? So all we have to do is think, hey, what quadrant is that? And you're going to say, oh, yeah, guys, come on, that's quadrant 2. Bam, that's all you needed. Quadrant 2, all right? Now, why is number 7 any different? Well, I see this negative sign, and immediately that's my red flag. I'm like, whoa, something's different here, right? But we can approach it the same way. We just have to remember that negative angles do what? I'm hoping that you're thinking that they go the opposite direction. So if I were to try and follow this around with the negative angle, right? So again, I'm going to start with 0, but this time I'll just put negative 90 degrees here, negative 180 here, negative 270, right? And negative 360. If you wanted to, you could really use a coterminal angle and make it positive and say, hey, same angle, let me work it out. But watch this. Let's draw our angle. So negative 90, negative 180, negative 270, not at 360, so it's got to be in between here. So let's just put it maybe like right there, okay? And this time my angle went around the opposite way, this way. So what do we want to say? What quadrant is that? That's right, quadrant 1, okay? And that's finding those quadrants. Now notice, some of your angles are bigger than 360, right? So you may need to bring that down using coterminal angles. Remember, you can subtract 360 from there until it comes down into the space that you need. And some of these are in radians instead, right? So you can see the solutions for these in the book. The PDF, this one is worked out for you on the key, okay? So just be careful. All you have to do is make sure you label these as pi over 2, pi, 3 pi over 2, and 2 pi. And you just follow it around the same way. All right, so let's move down a little bit. We're going to hit problem 16a. And what you'll see is it just says, let's convert. We're going between radians to degrees, and then 17 says, hey, can you convert the other way? Can you go from degrees to radians? Well, guess what, guys? All you have to do is remember a very simple equivalency, okay? 1 full circle was 2 pi radians. And if we divide that by 2, you'll remember that pi is equal to 180 degrees. That is radians to degrees, all right? So very simple. The way I remember it, whatever I am looking for, whatever unit I want, I put that on top in my factor, okay? So watch. If I wanted to change 4 pi over 3, I'm going to put 180 degrees on top because this is what I want, okay? And on bottom, I'm going to put what unit I already have. This unit was radians, so I'm going to put pi down here, okay? So remember, rule of thumb, guys, always what you want on top. So I want this unit, okay? And what's going to happen, very simple, my pi's cancel out. That makes my math really easy. 3 and 180, make that a 60. 4 times 60 is 240 degrees.
okay? Make sure you label, okay? Label your units. That is very important, okay? If you don't do that, you are throwing away the freest points that you can get. Trust me, you want all the points you can find, all right? So that's 16. And let's go ahead and do 17. So the difference between 16 and 17, not really all that much, okay? All we're gonna do is instead, we're gonna flip our ratio. So I've got negative 150 degrees, and I'm gonna multiply this time by pi over 180. And that's again degrees. I'm gonna put this over a 1, a little imaginary, to help me do the math. Let's cancel some stuff out. So here I'm gonna end up with negative 150 pi over 180. And notice these degree signs canceled each other out. Those units are gone. And so when we reduce this down, we will get negative 5 pi over 6, okay? Watch out, make sure you keep that negative sign. Okay, so you'll see the solutions for the rest of these in the worked out key for you guys. So make sure that you practice this, guys. Going back and forth needs to become very, very like ingrained, okay? You gotta be able to think like, oh, I can change between degrees and radians, no questions asked, all right? Just remember, simple trick, put the unit that you want on top. You want radians, put pi on top. You want degrees, put 180 on top. All right, let's jump ahead to problem 18, okay? So the next couple of problems, right, are starting to look at two major things, arc length and sector area, all right? So there's two key formulas to remember, all right? So the first one is the arc length formula. Arc length, we call it S, and that's gonna be R times theta, okay? Now, one key factor to remember here, R is my radius, theta is my angle, but theta needs to be in radians. Theta in radians. So if it's not in radians, what are you gonna do? Change it to radians, okay? Let's see if we can just figure out what all these pieces are, all right? So over here, I've got my radius. It seems to be 6 centimeters. And I've got pi over 2 as my angle. And luckily for us, it's already in radians, so we'll check mark, that's good. All right, so let's just plug everything in real quick. It's a simple thing. My arc length, S, is 6 times pi over 2. And that gives me basically 3 pi. And it's in centimeters, important. Remember our units, all right? And if we wanted to approximate it out, that's gonna be about 9.425 centimeters. All right, remember guys, put your units on there. Don't give away those free points. Take all the points you can get, all right? So you could write 3 pi centimeters or 9.425 centimeters. All right, so problem 21 now, okay? So 21 is talking about the area of a sector. Okay, that's the other formula I mentioned just earlier on the previous problem. So let's write out that formula. The area of a sector is going to be 1/2 theta r squared, right? So just got to remember that. And same rule applies. Theta must be in radians. All right, so keep that in mind. Don't forget that. Anytime you use these formulas, you gotta get it in radians. All right, that's super important. So let's see what information we've got. So the first thing I see is I've got my radius, 3.8 inches. Okay, that's good. Convenient that they told us that. All right, and then they mentioned a central angle of 42 degrees. There is a bit of an issue here. It needs to be in radians, and they gave it to us in degrees. So let's go ahead and just fix that. We're going to change the units for that, and it's going to be pretty quick. Just conversion 42 degrees times pi over 180. And I'll skip a little bit of the simplifying for you guys, and it gives you 7 pi over 30. Okay, so that is going to be my theta. Important. All right. All right, let's plug everything in now. So we're going to go ahead and say our area A equals 1/2 7 pi over 30. That's my theta. And I'm going to put r squared, so 3.8 squared, right? And since there's already some decimals in here, we can go ahead and solve this as a decimal. No big deal. So just kind of plugging the numbers in and crunching it out, and we should get that my area is equal to 5.293 inches squared. Okay, notice I squared the radius, so that's inches squared. Okay, make sure you get those units right. All right. All right, so number 29 is going to be the last of these problems that I work out. It's another word problem, and we're again dealing with the arc length or the sector area. Okay, this time it's a little bit different because it says, hey, can you find the angle this time? We don't have the angle. All right, so we're going to do the same thing, but let's think about what we need to know. All right, so let's draw a picture first. So they said a wedge-shaped piece from the pizza is cut. Okay, so I've got this pizza slice, looks delicious. So they've told us that the edge of the crust measures 4.4 inches. So let's go ahead and kind of mark that. So this edge right here, my pizza crust, is 4.4 inches. Okay, and the pizza was 10 inches in diameter. Now, remember, diameter is double your radius, so I'm going to go ahead and state that my radius equals 5. So what am I saying? If I cut this slice out of the pizza, the radius, right, is going to be these sides. So I'm going to go ahead and put that in blue. So this is my radius right here. This is 5 inches. Okay, that's my radius. This is my arc length. Why is arc length S? Honestly, because all the other good letters got taken from us, so they got stuck with that. All right, so let's go ahead and solve for the angle. Do you remember that formula from before? Let's rewrite it out if you forgot. S equals R times theta. Okay, so we're going to solve for theta. Let's plug in what we know. 4.4 equals 5 times theta. And if I just divide this by 5, I'm going to get my theta, and it's going to be about, let's see, 0.88. All right, so I've got theta. Great. Problem solved, right? Actually, no. We have a bit of a problem. We forgot that it said I wanted my answer in degrees. So we're going to go back and fix this. Let's change our unit at the end, right? What unit is this in currently? Radians, okay? Great, radians. So knowing that that's in radians, we're going to do the same conversion that we've always done. 0.88 radians times 180 over pi, okay? I know now this looks a little strange because there's no pi's here, right? You're like, wait, how am I supposed to convert this? Guess what? It's still radians. It's just like any other number. We're going to plug it in. We'll multiply, let our fraction reduce, cancel out. And in this case, we pretty much just use our calculator. We're not going to do this by hand. And we're going to get 50.42 degrees. And that is my final answer, okay? So that is the answer done in degrees. We initially solved it, but we have to remember, we always said that theta was going to be in radians, okay? So we just have to watch out for that. Make sure that we note, hey, my theta was in radians when I solved this equation. So that answer that I got there was in radians. but the question asked me for degrees, so we just have to keep an eye out for that, okay? So remember, guys, watch those units, make sure you label everything, okay? Try to take the rest of the problems as practice, right? Solve some of the questions that you thought were difficult, the question types that you thought were difficult, and you can check your work against the key that's also posted with this video, all right?